Hey, welcome to week 11 of BIM 1040. So this week we're going to deviate a little bit from the typical, and we're going to talk about project case studies. So just going through everything that we've done very quickly again, did an overview of BIM. We talked about the client requirements, the most critical, right? Setting the expectations from our external stakeholders, whether it's our clients or others. We talked about the BIM execution plan itself, what it means, concepts of BIM uses. We also talked about the level of intricacies, who owns models, components, etc. That led into software. So you need the software to model the stuff. Very simple, but there's the delineation between BIM authoring, coordination, collaboration, analysis tools. We talked about collaboration. How do we share the stuff, whether it's work in progress, shared, or published? Talked about the BIM uses. And here we just went through the various uses that are potential throughout a life cycle. And we had some ideas on, well, how does that affect the architect, the engineer, the contractor, the owner? We talked about the deliverable requirements that often feeds into what can be done, thus leading into defining a technical solution. This is the current assignment that's on right now. We then talked about the legal requirements. And the legal requirements were specific to the nature of what it means to be an architect or an engineer. We then expanded on that. So initially looking at the BIM contract appendix and what it means to start to infuse the BIM requirements into the contract itself, instead of just relying on what tends to be the case in the industry, where it's we shall do BIM and we'll define it later on in a BIM execution plan. And that BIM execution plan could have quite damning ramifications that maybe increases in scope with not enough fees, and it causes all of the issues around the myths of BIM, many of the issues. So that then we coupled last week talking into expanding on legal as it relates to project delivery. So the entire infusion of a project delivery foundational understanding as it relates to what I do and when I do it, leading to the most important piece of scope, schedule, and budget. So this week, we wanted to focus on some project case studies. So the idea here is for me to portray BIM in the real world and to help you as BIM coordinators understand some of the possibilities and the feasibilities that are out there. The hybrid portion of the course, so the self-directed portion, was going to be writing a brief project case study. And that would either be from something from your practical experience or something from you just analyzing and researching. And usually with a case study, what we try to portray are the successes and challenges or lessons learned of all things BIM, but in the real world. So we move from the philosophical discussion of how we could do BIM or how we should do BIM to this is how we did apply BIM, and therefore what worked and what didn't. Oftentimes we identify the goals, we identify the BIM uses, maybe the software and the hardware, etc. So that's what I'm going to go through today. It's quite a lengthy presentation, but it's going to give some examples, and then we can go from there. So with that said, I'll pop into the case studies, and similar to how I describe the software, building, civil, and plans, we'll have some similar examples here showing those differences. So just like assignment, the week 5 assignments, I gave you 3 project examples, and that's going to kind of feed into the end of this course. It is very important to understand that the application of the BIM process is quite uniquely distinct depending on the type of project. And I always describe the first set, I'm going to show our buildings, and just picture, your typical high-rise building or just a single-family house. It's a building, all the stuff's inside, sits on a site, and hopefully you show what it connects to. Versus water or wastewater or major industrial plants, where there's a major process that's the driving factor, or things like linear infrastructure, transit systems, where the process is going through the linear, as a colleague of mine once said, turning BIM on its side. So it's dispersed in a linear environment and may connect to your traditional buildings. So very different types of projects. So we'll start with the case studies. IBI divides into, stands for Intelligence Buildings and Infrastructure. So the buildings are obvious vertical infrastructure, and the infrastructure piece is our linear, and that's what we'll divide for. So a couple of examples from the world of IBI. This is the James Street GO station in Hamilton, Ontario. And the reason I like to show this, okay, again, it is a major multidiscipline project. The software used was Revit and Civil 3D. They started doing BIM early in the design to have concepts, and it was carried forward through to construction. Notice the BIM goals, and you'll see a lot of this, especially in the earlier days of where I work. The BIM goals are your primary or common ones: design review, clash detection, visualization. All of them, I don't mention design authorship in all of them where we have the models, they were used to develop drawings. So that's just a common thread. Clash detection was, explored here. And again, these are one of those early days where, clash detection costs money. Obviously there's the value of what you save relative to identifying the clashes early. But there's always that question of how do you run the clashes? How do you mitigate the clashes? All of that has to be accounted for. This project, it's one that I enjoy to talk about because it is that fusion of building and civil. Because it is a transit project, right? That bridge, that pedestrian bridge that spans the station to the platform is driven by the rail corridor. So the alignment of the rail network is one of the defining factors. And then the bus network, as you can see here, and then the pedestrian. So there's this fusion of multi-modes of entry, a transit-based process that drives the configuration of the building. This is similar, and I'll echo that in the plant projects where it is a plant-based project. And I think a couple of weeks ago I mentioned on those water treatments, you have to get the water from A to B. Well, the water doesn't get there, the project doesn't work. Same here. If the train can't stop at the station, or the buses can't stop to unload and pick up at the station, you kind of don't have a station. It doesn't matter what the building looks like. So, BIM was used to make sure that all the pieces and the parts fit together functionally, aesthetically, and then you're able to drive and improve value, etc. This is a bridge in Ottawa, the LaSalle Causeway Bridge. Actually, if you have the opportunity to go see it while you're at the college, that could be cool. It's a 1912 built bridge designed by Strauss. Not quite good documentation, as is typically the case with aged infrastructure. So one of the projects, BIM my existing conditions model. So there's a couple approaches that could have been taken. Now this was done several years ago. So, the initial one would be right now, well, go do a point cloud. Get a strong scan, and then maybe apply some scan to BIM technology. Well, 10 years ago, we wouldn't be quite in that situation. So they explored the use of Revit, as well as Tekla, Leap Bridge, and a couple of others. They stuck with Revit, and they literally did, this would be your LOD 500 model, a complete as-built, as-operated model, right down to the rivets and the machine components, a full 3D digital record of every piece of the assets. So it's possible. Now, in the normal or traditional sense, as an architect, I would never model to this great degree, but I show this because there is that feasibility where you can have heavily detailed models of this extent. And we do see this often in the manufacturer's world, in the manufacturing realm, where parts and pieces are modeled to this level and then sent to fabrication, etc. But an existing conditions model to this extent, fully done in Revit, is quite unique. Magna corporate office in King City. This was, again, a traditional building project. It was full multi-service building engineering and architectural fused together. Simple BIM off a ship. The whole point here was exercising strong design coordination through the 3D model, full engagement of the client in the workspace. And, it's when you look at this from the BIM professional world, it is a simple BIM, if you will, because it's only focusing on those three main BIM goals, yet the ability to, the ability of the BIM coordinator, or the burden on the BIM coordinator to ensure that everything is functioning properly and have the engagement of the stakeholders. That's a powerful piece. This is an industrial example, but it's industrial buildings. So this is for Honda plant in Allison, Ontario. So initially it was an expansion that we've applied the BIM process to for this client. The struggle here was, again, this infusion of a whole host of existing data and how to deal with that whilst providing the design services for the expansion. So again, you have multi-services, multi-disciplines, and oftentimes as a BIM coordinator, your question was, what do you do? So what is the right logic for existing conditions modeling? So I've heard now and know now that we do have the ability with scan to BIM technologies, as well as outfits that will go and interpret drawings for you to create models. So the question is, on a plant like this, where you're doing a paint shop expansion, do you BIM the whole plant? Do you BIM the connecting points? When I worked on some industrial projects in the past, we would BIM the points of interface. So maybe, 5 meters into the existing building, only at the interface points, so that you can ensure sort of coordination. But think about electrical and mechanical specifically. They're interacting. So how much do you BIM? Are you expanding the mechanical system into the expansion, or are you setting up a new one? And if you're expanding and they want to maintain airflow calculation and full intelligence relative to the mechanical system, they probably need to model the whole thing. But then to what extent? So there's a lot of questions there and a lot of interaction and understanding of, again, project need, scope, schedule, budget. Figure out what's done. Future-proofing, is this the first of many expansions? So then you lay the premise by modeling the whole thing. Is it a one-off expansion? Is it a quick design bid? Is it a full design build? All of the nature of the project delivery, the contract, and the desire or need will all define to what extent we can apply BIM. This is a French secondary school in Scarborough. Again, very simple, Revit and Civil 3D, BIM through construction. What I like, if you notice the BIM goals, scheduling and visualization. So there was a need here to portray how this building, whether that was to satisfy stakeholders, satisfy a client need, that I'm not sure. But that's an interesting one. The sub-consultant worked with the design team relative to the wall panelization. So that was interesting in that they were able to align the fabrication of the prefab wall panels relative to what was done in Revit and have that fusion, as well as they experimented and harnessed cost estimating as what they call the bonus BIM goal. So because the model was done properly, they were able to generate valid quantities in order to facilitate various cost estimates throughout the life cycle of the project. Another one up in Stouffville, Ontario, very similar in nature with the scheduling and visualization as part of the prime goals, as well as the cost estimation. But what I like about these, Revit and Civil 3D, so these two are traditional buildings, if you will, yet Civil 3D is included. And I always say buildings do not float. They interact with the ground, the footings and foundation interact with substrates of the ground, and there are utilities that the project has to connect into. Very important. This is a confidential project in Ottawa. If you visited some of the main tourist attractions, you may recognize it. The schematic design won a Governor General Award. MEP were all modeled in Revit to make sure that they could maintain their hidden nature as well as connectivity to existing. There were security requirements, heritage components, and huge complexity around curvature and shapes. So that was an intriguing one, showing the power of Revit specifically here in order to have a full representation of the true nature of the historical building, thereby allowing the retrofit to both complement the existing building and enhance and achieve the goals of the project. And there were also some linkages to an existing asset management system that were explored as well. This is a office building out in Calgary. So Revit was started from the beginning, and there was heavy coordination with the sub-trades and the model. So that right at the beginning there allowed for some intriguing validation of shop drawing and validation of components, linkages between our internal architects and external structural, live linkages allowing for immediate conflicts, your traditional BIM benefits, early BIM execution plan that was distributed and enhanced throughout the project, very critical, and that resonates through most, but it's worth mentioning. That is the Bible. That is the how we're doing BIM in this specific instance. So important. And without a proper plan, these often tend to fail. This is a park building for staff housing in Alberta again. This concept, especially for the wood frame construction, to have full live linked structural modeling, it's not that common in the industry. The smaller we get, the engineering trades tend to dwell in the 2D world. But pulling this over and having this this ability to have full 3D model coordination regardless of scale of a project. That's something that, there's still that perception that BIM is just for the big stuff. No, BIM is for any type of construction. Because there was the models, they were able to address for a major code change that happened in the middle of the project, and coordination with mechanical, electrical, and landscaping was facilitated even though those three disciplines were using legacy softwares outside of the BIM process. So there is a good example where you won't win everything, right? You develop a BIM approach, whether they're external or internal to your firm. You may have an entity that just says, hey, I use AutoCAD 2D. I use MicroStation 2D. Sorry, I'm not modeling. It doesn't derail the project, nor does it derail BIM. Just means there's got to be a bit of a workflow to coordinate that information. We have a lot of projects with intriguing facets or intriguing external components that can all be modeled and coordinated. This was a project that was joint between TPOL Architects and IBI, between our Edmonton office and TPOL's Toronto office. So there was the major coordination of the models between the various firms that had to be accommodated. The complex shape was the biggest benefit here. Oftentimes when we see projects like this, we're not quite sure how we would have documented this in the 2D world. And if you attend any conferences or see any literature, you'll see a lot of examples of this where BIM has empowered us to bring to realization some of the visions that are in our head, whereas in the 2D world, we may have struggled in order to accommodate that. And then having this model, the general contractor was able to, again, harness the complex geometric models in order to facilitate their work in realizing the project. Similar here, this is Park Casino. This is actually part of the Canada BIM Council tour back in January. There was linkage between structural and architecture to identify the quantities, your typical things. Mechanical did full routing of their systems through the model. So we did have multiple discipline coordination via multiple multiple entities. Therefore, there was a burden placed on ensuring model accuracy, sharing of the model. Clash detection was facilitated. So that, again, imagine the role of the BIM coordinator here working to orchestrate all of these various decision-making processes, awareness, data validation, data currency, etc. The client and the contractor were also able to gain a better understanding of the nature of the project, give the ability to drive through, visualize, and truly understand. And that's a big thing. And, when we think of the BIM world today, this whole program that Algonquin is lifecycle data management, BIM with lifecycle data management, we can't forget the initial value that these 3D models bring. And that value still resonates today in the fact that the project teams, including stakeholders, actually can visualize and understand what's going on. There's still that problem that people can't read drawings, people can understand the model. And that still resonates. So as we continue to advance the concepts and the abilities that we can achieve, or the capabilities we can achieve in the BIM world, we cannot forget the importance of that last comment there. In the UK, so this was an intriguing project. This was an infill project. This was done in our Brighton office. It wasn't a client requirement, but we felt that without 3D or BIM, we wouldn't have been able to achieve the project. So we had to fit a large quantity of healthcare services into a compact existing space. So they commissioned the point cloud. Notice here the client commissions. So this goes back to the legal last week, right, or 2 weeks ago. For decades upon decades, we relied on surveys, and when we want accurate surveys, we asked for them to be commissioned. So here, the existing conditions were commissioned by the client, and they gave us a clear understanding of the existing fabric. Okay, the existing was retrofitted to include state-of-the-art eye hospital. So it was an eye clinic. And you can see the compact nature of everything that had to fit into the space. And because they had Revit, because they had ability to phase in 3D and test, they were able to explore various types of spaces, find out what works best, what can be optimized, and then select. Now, this concept leads into what some vendors like Autodesk and Bentley are looking at relative to generative design. So we have spaces, how do you optimize the space, and how can we configure potentially a machine to use machine learning concepts to analyze thousands upon thousands of possibilities in order to yield the most efficient and effective results based on the criteria and the key performance indicators that we've placed into the system. So a lot of work's happening on the artificial intelligence end in order to help or further automate or further enhance, if you will, the abilities that we have within this realm to facilitate this type of design exploration. So that's an exciting world we're getting into. But again, remember my comment before, no matter how advanced we get, machine learning, artificial intelligence is all good so long as it can still be designed and configured to convey intent and ensure understanding. Critical piece of BIM, ensure the understanding. Chase Farm Hospital in central London. Revit was used to help mitigate the delivery of the packages. It achieved BIM level 2, which is defined by the British Standard 1192, with inter-office collaboration, as well as collaboration with external entities. So here we had mechanical, electrical, and structural models delivered from the consultants. There was 2D specific components. So this is a good example. Often in the BIM world, we're asked, well, when we're modeling, how do we do this? Well, we do this, but you don't model all of these finite minutia components. You use the model as the base upon which to have a deeper, a larger scaled overlay of the detail itself. That's a very important aspect. Multiple buildings, multiple offices, multiple practices. Media City UK, it's in Manchester. Again, a multidiscipline project with collaboration. Revit was the hub here. Again, there's questions, well, what do you do with the civil and the linear infrastructure coordination? They did explore Sefaria, which is a green building analysis tool, one of its functions. So they did that to approximate the annual energy consumption. So it's a pretty nifty tool there. You can feed your Revit model into the Sefaria engine, and again, depending on how well you model, your outputs around energy efficiency and compliance can be measured. So they use the LiveLink tool as well to help connect with the constructors. And this is an important concept because the UK was really at the forefront of what they call, what they call a common data environment, which is basically a common access point for consistent, accurate, and valid information. In the world of BIM, I talked in a collaboration session about WIP shared and published. This is looking at shared and published. So in that world, whether you call it a common data environment or a CDE, I don't care. The point is, how are you sharing the stuff that goes beyond, here's my model, we're authoring it. Once a deliverable is authored, whether it's a drawing, a piece of data, a snapshot of the model, whatever it is, it has to be reviewed, shared, delivered through publishing. It has to be commented on. There may be all other communications around these deliverables, and that's all information. Common data environment pulls all that data together and ensures consistency throughout a true life cycle of a project, and more importantly, the life cycle of the asset itself. So, and that's exactly what I was talking about here. So everything that happened through the life cycle along the supply chain is connected to the source information and therefore can be harnessed for further purposes. Very important aspect of BIM that often gets lost in reality. BIM coordinators often get sucked into the realm of, in a Revit project, linking Revit models, building content, sharing the models across the team, managing that collaboration system. Well, great, what happens when we're done? Where's all the data going? Who's tracking the design decisions? In a design build project, who's tracking the review and approvals and the actual transmission of submittals to the trades as things are being built on site? Who's tracking the deviations from the site and as they feed back to the continuing design that's happening in parallel? All very important. Simple example, I'm pouring a concrete wall. The form shifts or the wall shifts. I dig it over a foot by mistake, a meter, whatever. I've got to tell the architect that, hey, that wall is now in a different spot so that the building can be reflected accordingly. Very simple. How does that actually happen? Another project, it's a high-rise res scheme in Manchester. This was interesting. There were multiple block models, if you were, that were linked to an overall site model for coordination. So they allowed the buildings to work and facilitate themselves as isolated buildings, and then they were fused together for overall site coordination. So, and then they used the 3D capabilities to explore different facade treatments quickly to come to a complete resolution on what they actually wanted to achieve. So this is brings up an interesting question here. How do you accommodate a project like this? Do you have one model? Do you have multiple models? How do you split it? That's one thing that was explored here, and that comes to the BIM coordinator all the time. And I've seen it on many projects where it's a campus of buildings or a collection of buildings. Don't jam everything into one big, massive bucket of Revit stuff. Don't do that. So depending on Revit, Vectorworks, ArchiCAD, EcoSim, etc., there are different technological capabilities relative to how to split models. But fundamentally, regardless of what software is being used, a project like this very easily lends itself to 3 main building models that all come together on a site. It's very logical. Depending on the size and complexity, you may divide the models, maybe divide them in the middle. I don't know. There's nothing right, nothing wrong. You may get exposed to software limitations that have to be explored. But at the end of the day, if this whole project was one big monster model, that wouldn't be good. I've seen other examples of divide them into three, but then do facade as one, core as the other, so core and shell models. Definitely, I've seen division of disciplines. So architecture and structure, maybe separate, maybe together. Mechanical, separate. Electrical, separate. There's always the debate about interiors. Furniture and layout, separate model. Just a work set in one model. Explore. That's all I can say. There's no right, there's no wrong. The other developments in a nutshell. Explore Kobe if you have the opportunity. Out of Salt Lake City, this was a project that we developed all the subs working in Revit, all the models linked together. So we had external and internal. I don't want to call those collaboration nightmares, but those are things that require collaboration attention. You saw in the week 5 assignment, I was very specific in identifying when the teams were internal versus external. They explored how to deal with multiple repeating elements, so suites that were common on various floors, how to allow for those, how to design them once and follow them up, or design it once, build it once, utilize it throughout the complex. And then a lot of exploration with SketchUp and importing from SketchUp into Revit. Always be very careful. You don't want to convolute the BIM models with unrequired information. Yet you'll have conceptual designs, and we talked about this in the software one, that come from tools like Revit, Rhino with Grasshopper, SketchUp, or various other tools. BIM is not there to hinder the ability to generate a proper conceptual design, but always look at how to best integrate components that come from foreign applications. A science lab building. This was a project that started in AutoCAD and then modeled in Revit. And the reason it was moved to Revit was to achieve construction verification, renderings coordination, etc. Navisworks was used for design review. What's interesting about this is that the clients pushed this project into the BIM world, and once that was done, several clashes were found that were not exposed during the 2D design. So because the modeling was done post-design, pre-construction, we were able to save a significant amount of clients' money relative to what would have had to be either change orders or adjustments during construction. So that's what I'm saying here. So it's interesting here that, this is an example where, for whatever reason, the project started in the 2D world, and the value and benefits of having a coordinated model were exposed thereafter. As BIM coordinators, we will not always win. There will still be 2D out there. In the perfect world, everything would be BIM, but slowly those who are lingering to the 2D CAD process will be converted to the BIM world through examples of what I'm describing here. It's a school in Washington State, US. Again, it was initial Revit and SketchUp fusion from the very beginning, and then everything merged into Revit thereafter. So very simple. Just wanted to show that the SketchUp model you're looking at here. This is to help portray the fact that you can start BIM void of traditional BIM authoring tools. And something like SketchUp is becoming more and more intriguing because they are working to, they are able to export to IFC. So the ability for SketchUp to actually have IFC compatible components that can then feed into formal BIM authoring tools. So just keep that in mind. The material takeoff was an interesting BIM goal, as well as daylight studies. That's an interesting one. It could be used for sustainability requirements. It could be used just to prove to the client that this is how we believe the light will filter into the building and where we will have potential areas of lower light or darkness. So very valuable. All of these, I hate calling these push button abilities, but a lot of BIM goals may not carry an extensive cost, but may bring a value either to the client or to another stakeholder. Again, material takeoff, it is sort of a push button. And notice I say that, not cost estimation. Cost estimation is a profession. A material takeoff is scan my model, here's what I have. Now do what you want with it. That only works if you have a good model, right? That's always the crux with a lot of these. Daylight studies, it works beautifully, right? Put it in, Revit has some built-in daylight study capabilities, bring it into other systems, it can do it, but something very fundamental. What if I model the glass as an opaque solid panel? Guess what? Daylight studies failed right there. So something as simple as that. I built my curtain wall in the BIM tool, but I didn't call the glass. The glass, it thinks it's brick. Daylight fails. So remember that. Similar with the material takeoff. If a column is called the beam, if a floor is called the wall, and those are silly examples, but I use them, I continue to use them because it does happen. What if a circular duct is modeled as a pipe instead, right? Simple things that look right, or as a conduit, right? Look right, but material takeoffs would be completely wrong when these components are misidentified. School in Texas. Revit and AutoCAD for both. And that's always intriguing, having that fusion. Revit at the beginning to end together to produce a whole. And the question is that a challenge? It enables collaboration with a different office, but the question is, how do you deal with the challenge of split models? And especially when you're using authoring tools that are dependent on on the central model concept. So like your Revit and your ArchiCAD. The bigger the bucket, the easier it is to manage because everything is together in one. Using a tool like EcoSim, it's a full federated approach. Therefore, all the model, I can divide a model, a building into 100 models. There's no issue with linking together all of the mini models to either do takeoffs or visualization or to create my drawings. Whereas if any of you have used Revit, you know when you link models together, the linked model is a big block. So you have the visibility graphics issue, you have all the wonderful Revit issues that show up. So I get it, and that's why when the Revit is being used, as a BIM coordinator, understand that we have to address the software limitations, okay? And that's why I think in the first class I said, if you have the opportunity to learn or just be exposed to other pieces of software, do it. Internally to IBI, we had access to some free Bentley EcoSim tutorials. It was like 2 hours a day for 4 days. I had 4 of the BIM coordinators just sit in and listen, just so that they understand the perspective that I've seen, and they can be cognizant of the fact that, you know, BIM is not defined by the software limitations. We just have to adapt the process, often depending on the software itself. So that's a collection of a wide collection of buildings, and that's your traditional. We got a building, multidiscipline. You know, how do we do it? The infrastructure side of IBI gets a little different. So this example I'm showing, it's a full linear project, no building. This concept of a municipal BIM ecosystem. And if you Google civil BIM, there's some white papers that have similar diagrams. It's all about the management of information relative to specific assets. That's where we are in the linear world. There's an archive of data, often in the GIS environment. You field verify the data. You assemble data from various sources, do some type of a design, gain your approvals, construct and inspect. post-verify, and then you have your as-built record. A very common workflow, applies to buildings as well, but very common in the civil world. Civil 3D model, this is an example. You have the realization of the assets that you track from that 3D model. So oftentimes, buildings BIM people look at that and say, "Oh, that looks 2D to me." But no, that is very 3D, representing the location of all of those assets buried under the ground. And then you have assets that are exposed above ground as well. Eglinton Crosstown LRT. This is a mass transit project that IBI is working on. 15 station, various stop, elevated and buried infrastructure. 15 total design partners. Imagine the logistics around collaboration there. So that week 5 assignment, very similar to that project number 2. This is a P3. So design, construction, and operation were kind of happening in parallel. Focused design goals, expanded goals for construction. Now here the unique thing was, as we were BIMing for design, construction were BIMing in parallel. So they were taking design models that were being purpose-built for those design uses and trying to expand on those for construction whilst the design models were continually in flux. And that's been going on for 2 years. So there is an intriguing challenge to maintain coordination throughout the project. 2 focus areas, there were the vertical stations, the linear infrastructure, a fusion of Revit and Bentley Inroads, Revit for buildings, Inroads and InRail for civil linear. Navigator and Navisworks were both used as review tools, and Bentley's Project Slides was used as a central hub for all of the information. And this was all project information, not just the Revit models, not just the MicroStation DGN files, but all of the transmittals and submittals and the project documentation, all of the non-CAD information was fused into this collaboration system. Example of the review, and take note of an area like this. So I always describe it. Here's the above ground, 2 portions. Everything else is buried. The mechanism to get down, the underground rail network, and all of the mechanical and electrical and instrumentation and communication systems required to operate and run a rail line. This is our example mobile navigator that you can actually take your buildings and review and fuse. There was an interesting requirement, and this happens on most transit or linear-based projects, where you've got to coordinate the base points based on some type of underlying process. Here it's the rail track alignment. So we were using the base points versus survey points to coordinate all the various systems. This is an effort in itself to build a proper understanding of transition of ground survey information to grid survey information, bearing in mind the geospatial restriction that is housed within the Revit environment. If you were doing these stations with Bentley EcoSim, this survey base point, all of that's irrelevant. But in the Revit world, you're confined. So again, the BIM workflows, the application of BIM catered and restricted, if you will, by the limitations of Revit. Keep that in mind. When you're geolocating your Revit models, your shared coordinates, publishing and pulling coordinates, are you dealing with a MicroStation deliverable like we were here? And because of that fact, we couldn't publish shared coordinates. Therefore, we had to build a proper workflow to accommodate. And that's what we had here. Not going to go into detail, but this is something that I had to build with the assigned BIM coordinator to work through how do we facilitate building-based Revit coordination, generate our sheets, get our sheets to the MicroStation platform, and get the CAD standards to be compatible to a very stringent 2D CAD requirement to meet the delivery and the reviews that would be put on those sheets. Very, very challenging, and this was a burden to the project that we had to accommodate. So keep that in mind. As a BIM coordinator, I keep saying we're the orchestrators. You may not know anything about MicroStation, but if you have a project that has a rigid MicroStation deliverable, you better start asking some questions. You may need some training. You may need to engage some expertise to find the solution that allows you to meet the project requirements. So, contractor was exploring the use of the Bentley I as well as the raw digital files in order to facilitate their. Next, we're going to talk about the Viva Next project. This is a bus rapid transit bus corridor that is occurring up in Highway 7 in Vaughan. And here we had three main design partners, so a little less. This was interesting in that this middle portion is already constructed. And then we're designing the portion on the east and the portion on the west. Here, it was again a P3 project, and we did full linear BIM implementation. So a lot of items were modeled. Our BIM goals were drawings and schedule production, design review, visualization, as well as quantification. And just take note here, I always pause on this one. This here is a clash between a proposed pipe and the eventual size of the root bulb of a tree. So imagine that, a temporal clash that we had to deal with. When the tree is planted, no clash. In 10 years, when the root bulb is expanded, potential clash, and it was adjusted. All of the information was exposed out of this simple 3D environment into our BIM review tool, which was Navisworks. This project won a couple of awards, one being the Ken BIM General Contractors Award, as well as an AEC award from Autodesk. We focused, and we were given the opportunity to prove what was called enhanced design, and if we were able to prove a multidisciplinary integrated project, we were able to skip one of the scheduled deliverables, thus saving time, saving money, saving budget. The only way to prove that we were reviewing and resolving conflicts was to have the full 3D BIM model and go through the process of design collaboration and clash detection. So the BIM technology, again, it's 12 kilometers, almost 400 million capital cost, multiple companies, aggressive schedule. And that aggressive schedule was interesting because we did have multiple submissions that were happening over and over and over again in parallel. We needed to have mobile access, intelligent document control, and a 3D workflow all happening live, and this is what helped us to prove the enhanced design. Multiple platforms, so we had inroads as well as Civil 3D, and that was to help for road surface design as well as subsurface design, ProjectWise is our common data environment, and Navisworks for our conflict resolution, and multiple deliverables, as you can see on the left there. All of that helped to feed the BIM execution plan. So all of this was fully documented so that we were able to guide our teams to achieve this. We had modeled electrical posts, electrical lighting with foundations, telephone poles with foundations, sewers and catch stations existing in new utilities, root bulbs, landscaping, etc. Everything was here. Everything was analyzed. Clashes were detected, like you can see right here, and then mitigated and resolved accordingly. Drawings were developed straight out of the models, identifying where the components were, their elevations, full 3D, full analysis, relation back to the surface. Live ProjectWise for the authoring of the AutoCAD-based files for Civil 3D. We talked briefly about that data shortcut project. That basically is the definition of data components within Civil 3D, a pipe network, a surface, an alignment, shared across multiple files, shared across multiple organizations. IBI had multiple offices from Canada, Western to Eastern Canada, including India, external entities that had multiple locations as well, all shared through the live environment. And then, as I said before, we were able to skip a formal 2D submission because we were able to prove and demonstrate the live collaboration environment empowered through the BIM process. The I part of IBI is our intelligence sector. And I like showing this as an example to show you can have BIM without your typical BIM. So this project here was 16,000 kilometers of roadway for Highways England. We've developed an asset management system that focuses on cataloging the life cycle, the condition assessment of assets throughout their life cycle. We harness GIS tools that we branded as Route Mapper. Doesn't matter where the data came from, it's what we're feeding it into. 64 asset types cataloged through this hub. We quite literally drive around the 16,000 kilometers, assess the assets, analyze their current conditions, take LiDAR scans, feed everything into the system, and bring all that data together. Photos, where it is located in GIS world, the existing conditions, analyze, provide feedback to the client then able to assess, plan repair, replacement, and help that feed into their environment. We have another tool called Arch Control, that allows us to manage the development of land development subdivisions. It gives a repository of the information, so what's been designed, what are the drawings, the types of models for each parcel of land, what types of materials are being delivered to the site for each specific parcel, what decisions have to be made, gives an interface for the stakeholders, maybe the client or the ultimate homeowner, to go and select. And then it allows us to analyze what's been delivered, what's been installed, what's in process, and there's a mechanism for us to view, analyze, interpret, and communicate between stakeholders, clients, and consultants. And this is, again, an IBI-built tool simply designed to be a focal point or a hub of data to enhance the process of subdivision land development. We have another one called Maintenance and Inventory Management System, and I think I showed a bit of this. This one's particularly when we were talking about asset management, but very simple concept. We've got a bunch of assets with unique asset IDs, and we have developed linkages to BIM. The system itself initially started as a simple database that allowed us to catalog assets for departments of transportation in the States. We came and said, well, let's do a BIM connection point. And the lesson here is the tie back and the power of the Open BIM standard. So here, using our office example, this does not connect to Revit or EcoSim or ArchiCAD or Vectorworks. Those are all software-based proprietary tools. APIs could be open, quasi-open, or closed. All of those software, though, have committed to the ISO standard of the Industry Foundation class, thus empowering Open BIM. The minute I get this model to IFC and ensure that the required assets are representative both as a geometric representation as well as the required data backbone, I now have this fusion of data and geometry in the open environment that allows me to harness and connect to other systems. Then I'm able to access the information here to report on, to report on the information and allow us to have unique types of assets, etc. Next, I'm going to go to some other projects that I've worked on in my career. Sorry about that. So this is a porch renovation. So this now touches upon the scalability of BIM. Large BIM to small BIM. And you don't get smaller than a porch. So for the homeowner, I modeled the existing to be demolished, and I was able to quantify what was being demolished. So I was able to identify, really the benefit of this was to help show exactly what was going to be the size of a garbage bin, if you will. How much concrete, how much existing rail, how much of the enclosure was going to be laid down, broken up, and placed into a box for waste removal. We then modeled the new porch reno, and I was able to very quickly quantify volume of concrete, linear of handrail. The simplest thing, how many bags of concrete does the homeowner have to procure? How many components of the handrail? Simple BIM, monitor the construction, and see the output, right? This is BIM to its most finite element, if you will. Valid project, small scale, able to be done. Another small one, and I'm showing you this because once you see the large vastness of what you can do with BIM, don't lose sight of the simplicity. Model a kitchen. This isn't even a whole house. One room in a single family house showing how the orientation and configuration is going to be to help to give an understanding to the homeowner of what they might end up with. Quick drawings to generate and give to the kitchen manufacturer. And also specific elements that can be modeled and delivered to a fabricator. This here being high gauge steel panel. They weren't able to, or they didn't have the tools required to cut through 16 gauge steel, stainless steel, so 16 or 22. So what we're able to do is send this off to a local manufacturer with the dimensions pulled straight off of the model. Panels are fabricated, delivered, and easily installed. Also, from the quantities perspective, I was able to very quickly generate the quantities on the left that they were able to then estimate based on unit pricing in order to get a potential cost for the components of the kitchen. So why? Again, we were able to analyze the differential of what was estimated versus what was actually spent, and then here the homeowner made a decision for a different type of counter that drove the cost up. But what's interesting there is even in the smallest scale project, scope, schedule, budget, I was able to analyze what was the difference, what was the budget, and what was the difference in the actual spend. And you will have this as fundamentals of project delivery. You will have this regardless of the scale of your project, and your influence as a BIM coordinator will help to drive how and why and what the reasons are for price differential. And that's why I like to show this example. Small scale, kitchen reno, there was still the full analysis of BIM, multiple BIM uses from start to finish. So this last project is one I did when I was at CH2M. I'm going to go through this one. This is a plant-based project, and this is one that was quite intriguing as it started off as, well, first of all, it's an award-winning project, so there's links to those there from the Bentley Be Inspired. It started off as a BIM My Existing project. So 60-plus-year-old wastewater treatment plant with little to no existing information, $20 million upgrade. So quite a large or a massive expansion to the project. The initial thing we did was understand that the concept was to document the entire plant as an asset for the community, and therefore they wanted to BIM all the existing non-process buildings, existing interiors of process, and generate intelligent P&IDs, and one of those process instrumentation diagrams of the entire treatment. So remember, this is an industrial plant. The root reason for plants is what's happening inside, not the buildings, not the roadways or the transit ways, but the movement of the process. If it's a food packaging plant, it's the ability to have the food come in, have it get packaged, and have it leave. If it's a water treatment plant, source water comes in, water gets treated, source water is delivered, or treated water is delivered to the delivery system. In a wastewater treatment plant, raw sewage comes in, the liquid is treated, the solids is treated, the solids are distributed out for fertilizer or whatever, the liquid is distributed out back into the ecosystem or as a base to a water treatment plant. So understanding that fundamental to say the information that we're pulling together, that we're fusing and we're connecting has to facilitate that process or it is a simple failure, period. And there was a linkage to a facility management system as well. So this is an example of those diagrams that I had you do in one of the first assignments. This project started with ProjectWise as its hub. So it was using that as a collaboration system. We had Inroads for our civil. We had EcoSim for our building. Those two systems spoke to each other quite nicely. So unlike Revit and Civil 3D, these were simple referencing, live data, and they both fed the MicroStation deliverable requirements. In the plant world, we had PlantSpace, which is an older system, but it was what existed at that time. Used a SQL database platform that fed to PlantSpace the spec-based requirements for the piping models. Now, we talked about the data requirements in previous classes. Well, plant modeling is the type where, I think the example I used, I can't make a 2-meter diameter copper pipe because the material doesn't do that, nor can I do a 1/2-inch reinforced concrete pipe because that would just be foolish. So the SQL database has all the rules and mechanisms upon which I can then do my piping model. So it ensures the quality and consistency of that information when I'm in the model environment. And because it's all, in this instance, all the DGN platform, I was able to live reference building and civil, and we had a pure synergy of everything feeding the MicroStation-based deliverables. We used the OpenPlant P&ID tool as our engine for the intelligent P&IDs that to also had the SQL backbone, and with the common deliverable was able to feed into MicroStation. At this point, we used a new tool that was called Bentley Raceway and Cable Management, yet it now is mainstream. We used it for the modeling of cable raceways and conduits, again, all DGN, all fed into MicroStation. So I had this full synergy that allowed me to deliver my DGN deliverables, my I models, and again, we had some Civil 3D that we had to play with. Navigator was used for my design review, as was Adobe, which we'll talk about in a moment. The Civil 3D portion was an external sub that did a portion of the project in Civil 3D, as was a requirement by the client, and we were able to deliver that. So ProjectWise housed all the information. 8 unique facilities, I models generated for each, 8 offices, 1 external entity, 15 gigabytes of information shared in a live environment. We're able to share live reference files for all of the BIM models, the flat 2D files, large base maps, central shared models were needed. CAD data sets were shared project-wide for both AutoCAD and MicroStation. We had our templates and the client delivered standards and context. Everything live in one single environment. Defined BIM uses. You could see the simple uses. There's drawings, construction review, or design review, visualization. We did perform clash detection, and we had the linkage to the owner asset management. Clashes were reviewed, communicated to the interested parties or the stakeholders. As they were communicated, they were mitigated and resolved, all managed by the BIM coordinator. A lot of the clashes were based on process equipment relative to building components. Those are the main clashes that were analyzed. As I've said in the past, with these heavy industrial projects, these equipment pieces are usually the heavier or the larger pieces that have to be analyzed or that are of a greater cost, and therefore any clashes with them will have a larger detriment to the project. So we tracked the clashes, analyzed them, and then communicated accordingly. We did create PDF deliverables of all of the existing, and in order to do that, instead of trying to recreate all of the old legacy drawings, we used the iModel plugin to Adobe PDF. So it's an extension of a 3D PDF, if you will, that allowed us to maintain the intelligent information from the Bentley models to be accessible inside the PDF environment of Adobe. And the client was able to then analyze, review, and consume what was actually being done or what was BIMmed for their existing conditions. And the beauty of this is it's basically taking the model and making a deliverable of it, and the client could explore and interact, but actually have literally starting snapshots of the model in the digital environment, allowing them to have a full understanding of what was accomplished. We infused or linked to the asset management system, and for here we developed or identified what we called assets of importance. So here it's a process, so it's mostly pumps and valves and heavy equipment, not floor finish, wall finish, etc. So here we had existing pumps, as identified here, pump 1, pump 2-2, here's pump 2-3, and all of those fed into a operational system. And this schematic matched the intelligence schematic, showing that the pumps controlled the centrifuges that were downstream, and those centrifuges were connected to another portion of the model, which was linked to the operation and maintenance manual. So this dialogue, if you will, this hyperlinking dialogue was worked closely with the owner and operators at that time to allow us to facilitate this data synergy and data movement. Very unique deliverable, obviously required hand-in-hand collaboration with the owner-operators, but achievable technologically through simple hyperlinks. That's all, just hyperlinks. Next, we're going to move to the London Olympic and Paralympic Games for 2012. Very quickly, this is a massive scale project that I had the pleasure of working on for a couple of years, literally from 06 to 08. So the program had multiple stages: land remediation, design, build, install, run the games, deconstruct, and you have legacy. My portion, so I was part of CH2M Hill at the time, who are the C of the CLM, which would be CH2M Hill, Langer Rourke, and Mace, that were in a joint venture managing the design and construction of the games. I came in right about here as we were focusing on land remediation and starting the premise of the design. So we were located in Canary Wharf, overlooking Stratford Village, Stratford Park, which is where the games were held. 9 main venues, 670 acres. Earthworks, bridges, and road. My role was not to help in the design of Olympic Stadium or the Aquatic Center. It was in the interaction of the information. So teams would go off and design their venues with their subs or whomever. All of their venues had to interact. So Olympic Stadium had to interact with the parks and the waterways and the pedestrians and the bridges and the roadways and the buried utilities. All of the network of infrastructure had to interact. The beauty or the complication here was, as this was occurring, all of the major infrastructure that was already existing had to stay operational, specifically London Underground, overground rail. We couldn't disrupt the Crossrail project was happening in parallel as well. So there was a lot of new and existing infrastructure that were occurring outside the project that had to be respected, a lot of new and existing infrastructure that had to be dealt with inside the project, and the integration with all of the new facilities and components. Wonderful project, ridiculous complexity, had to be dealt with. So with that, from a BIM case study perspective, tons of examples here. So the idea, obviously, of this week was to expose the BIM coordinator really to what it means to have a case study. I'm all about, visual case studies through presentations like this so that they can be continued and furthered and portrayed in various means. So in closing this week's live session, I did want to obviously, had the work stoppage not been happening, we would have looked at some of your case studies, but just expose as BIM coordinators, you should really capture and understand anything you've done, whether it's for your own personal resume, whether it's for selling the BIM potential within your organization to projects or to various external organizations and clients. Work on a project, understand what you did well, what could have been done better, concepts of lessons learned, talked about last week in project delivery, and encapsulate the case studies. What was BIMmed, why, and how? An image, get a simple slide. And you saw some of these slides. One simple slide of a BIM case study allows you to talk about it, allows you to tell the story. One slide. Do that for any BIM project you're associated with, and it allows you to build a record and a reference of what you've accomplished. So this week, the end of week 11, we do have a quiz that's opened up. So please be mindful of that. Going back to the quizzes, again, I I'm asking you to give proposed tools for BIM authorship review and collaboration. So when you can, have a look at that assignment, and you can submit that accordingly. Obviously, I will be augmenting this due date to when the work stoppage is over. So I'll push it now down to the end of the month, and then we'll see. Actually, I'll do that right now for you. I'll change the due date to November 30th, and if the work stoppage hasn't resolved itself, I'll just keep pushing the due date of assignment 8 further away. So right now we'll set it to the 30th. And with that, I will submit, I'll put an announcement up here upon completion of this week. So week 11 virtual, similar to week 10, I'll add the links to the week 11 and I'll keep the links to the 2 quizzes, or sorry, to the assignment, week 9's quiz and week 11's quiz. Thank you for your attention. I hope you enjoyed this. Next week, just a preview of next week. I haven't opened next week yet. Week 12, which currently is scheduled for November 24th. If the work stoppage is done, we will be talking about BIM use workflows, and we'll get into particulars on how to build a workflow. So the hybrid portion is for you to build a sample one. We'll look at what's been delivered from Penn State. I've got a bit of a presentation about that. I'll look at some custom ones that I've done, and then we'll talk about that final graded assignment. That's all next week. And then, as mentioned in the announcement, I'm on vacation, so I'll be completely offline for December 1st. So I will look at what to do with week 13 and 14. If the work stoppage isn't over, I will have a recording for week 12 prior to the 24th. Thank you, everybody, and have a great day.